Okay, today's lecture is about the history of innovation. We'll talk about innovation in the ancient world and the Renaissance, and give some background to innovation crossing both science and art. So lecture number 3, History of Innovation, Ancient World and the Renaissance. So as you know, there are 2 parts to this course. We have the first part is the fundamentals in history. We talked the last 2 times about an overview of innovation and the key example of evolution and biology as a paradigm for evolution. And today, of course, we'll be talking about innovation in the ancient world and with a focus on the Renaissance and innovation, Leonardo da Vinci, Michelangelo, and all that. The second half of the course is on specific methods and applications. So here's a question for you. Again, we didn't have a specific assignment other than the reading of Waves, the first 3 chapters. In your opinion, who is the most innovative person of all time? So I'm not going to have everybody answer. I'll call on a couple people and tell me what your opinion is very briefly. So let's go with Kong Yong-che. Kong Yong-che. Kong Yong-che.
Yes.
Great. Who is the most innovative person of all time in your opinion?
I think the most innovative person is Elon Musk, the
Elon
Tesla
Musk.
owner.
Yes. Okay. Very good. Good answer. We're going to talk more about this over the course of the classes. Let's go with one other person. Park Shi-young. Park Shi-young. Who do you think is the most innovative person of all time?
Yes. I think the most innovative person of all time is
Difficult question.
It's Einstein, because
Albert Einstein.
Nowadays I am studying about the physical chemistry, and in that in this class I always feeling that he is very innovative person.
Very good. So remember, the definition of innovation is not just creative and interesting new ideas, but making that into reality. And both Elon Musk, who has made many things into reality, and Einstein, who was a pure scientist, but he wasn't just doing some equations and his mother and his professor or his friends say he's very smart. He actually made his ideas out into the world and accept it and impact. So he was innovative like that. There are many smart scientists that don't have any impact. We don't call them innovative. They may be very creative, but they're not innovative because they didn't make that impact. And Einstein was definitely one of those. So that's a very good answer. Again, there's no right answer. This is more for discussion. One more person, E.Q. Hwan. E.Q. Hwan. E.Q. Hwan. Oh, your microphone didn't work. I apologize. Let's go to Park Min-ji. Park Min-ji.
Yeah.
Yeah. Most innovative person of all time.
I think Steve Jobs is the most innovative person because he made a lot of smart things in reality.
Great answer. That's right. I mean, there's no right answer, as I mentioned. This is not a test. But the point is, Steve Jobs had some great ideas, new ideas, but he made them into reality. Apple computer exists, the iPhone exists, and so on and so forth. So Elon Musk, Albert Einstein, Steve Jobs. In a later lecture, we're going to study Albert Einstein in more detail. And I've actually given a seminar, some of you may have seen it, about Albert Einstein and why he was not just a pure scientist, but very good at bringing his ideas to reality. So thank you for the discussion, and let's continue. So in all our lectures, we do a very brief review of the previous week. And as you know, last week we did innovation in biology. We talked about three things: examples of innovation in biology. We discussed the theory of evolution as a paradigm for innovation. And we talked about bioinspired or biomimetic innovation. So by examples of innovation in biology, there are many of them, of course. So I just selected a few. One is the four-cusp molar. The molar is the back teeth here, and the cusps are here, and there are four cusps of the back molars or rear molars. And that sounds like a very simple thing, maybe not so exciting, except if you're a dentist. But that created a lot of possibilities and expanded the diet, improved the energy efficiency and effectiveness of early human beings to be able to find food and support their diet. And so it expanded the diet and enabled a lot of other things. It's a kind of an enabling and innovation. Another innovation is that of bone, which we know is a composite, a fiber composite. And it's composed of protein, collagen fibers, and basically solid calcium-like rock, limestone. Those are combined to form a fiber composite. And this is the hierarchical basis of that: the protein in green and the hydroxyapatite or calcium phosphate deposited increasingly between the calcium. So this is 0% hydroxyapatite, 20% and 40% to create this hard but also flexible substance, which we call bone. Another example of innovation in biology is the Darkling Beetle, extracting moisture from extremely arid or dry environments in the desert. And its back, its surface, is a combination of hydrophilic and hydrophobic materials that bring the water vapor that is, down in channels towards its mouth, and it can extract very small amounts of water from the dry air. So this leads to the concept of bioinspired innovation with this alternating hydrophobic, hydrophilic surfaces. Hydrophobic meaning resisting water, hydrophilic means binding well with water. And so those alternating surfaces can be used also in extracting moisture from the air, creating fog-free windows, mirrors, and other applications in a bioinspired way. So we talked about the theory of evolution, which we will talk about or reference throughout the course. And there are three features of this evolution. First, we have a genotype. The genotype is the DNA of the organism, and that has the information that can be transmitted. So hereditability of fitness, or transmitting the information, transmitting the ideas, sharing the ideas, is very important. The second one is the phenotype, was the expression of the DNA, namely the body, the behavior, how it is actually functioning in nature. And there are two aspects to this phenotype. One is phenotypic variation, so that there are different types of organisms in a species, and they interact differently. In other words, differential fitness with the environment. So some characteristics are better for certain environments than other characteristics. And so this dynamic of hereditability of fitness, phenotypic variation, differential fitness is a fundamental dynamic of innovation. And when we talk about the history of innovation shortly, we will be referencing this framework. So thirdly, in terms of review, we discussed bioinspired innovation. I gave a whole list of various institutes and projects. One of them is the Wyss Institute, which does a number of technologies based on bio-inspired concept. For example, air purification related to the butterfly wing, and DNA, which we know stores information, as a exemplar or paradigm for storing DNA information in future memory systems, molecular biocomputing. So that's the review of biology. Again, some examples of innovation in biology. The theory of evolution is a fundamental paradigm to help us to understand innovation. And thirdly, bioinspired innovation. So let's talk now about history of innovation, in particular innovation in the ancient world, top innovations in the history. So again, the theory of evolution with these three features will focus on big innovations that related to differential fitness, big innovations that related to phenotypic variation, and historical innovations that were related to passing on the information or the hereditability of fitness. So let's focus first on very significant historical innovations on the hereditability of fitness. And so you can see here in the upper right, we are zooming in on this. Obviously, these innovations have many features, but one reason why these are so important innovations is they are what we call enabling innovations. They're innovations that help create other innovations. So if we want to transmit information, well, the movable type or the printing press was one of the major innovations that enabled that. That, of course, was developed by Gutenberg around 1440 in Mainz, Germany. Now, all of you are students in Korea, and you've no doubt learned that Gutenberg was not the first one to create the printing press, but actually that was a Korean invention. The Jikji came before Gutenberg around 1377. And in fact, there are reports that the Chinese had a printing press even before that in 1040 and so forth. Now, you may say, well, I'm from the United States, I'm a Westerner, therefore we take Gutenberg as the inventor and so forth. I'm not talking about the first invention. I'm talking about innovation. And remember, innovation is not just about invention, it's about making something real. So when we say that the Gutenberg Bible was the innovation, that doesn't mean that the Korean or the Chinese invented it first, but those two were limited in their application and did not spread out through both domestically as well as globally. There were social reasons for that. The Chinese emperor didn't want so many people to have all sorts of information. So there were limits to the spreading of books and printing presses in both of those cases, which was not the case with Gutenberg. Therefore, it became an innovation. And this is a very touchy point because people say, oh, Gutenberg was not the first, the Koreans were the first, and we're the best, right? Well, this is not about being first, it's about innovation. And so the other lesson from this is that you had smart people, Korea, China, and Gutenberg invent the printing press. But only one of them created a widespread innovation. And it's also not up to the individual, but also based on the situation around that individual. If society, if the situation does not allow the innovation or the invention to proceed, then it won't happen. And remember, we said that invention comes from individuals, but innovation from groups. And when we mean groups, we just not just mean the team, but all of society in some cases has to come together to make that innovation possible. So this is a very important point. So a single press, instead of writing a hand document 10 pages a day, perhaps could do thousands of pages a day. And by 1500, in less than half a century, or about half a century, there were 1,000 presses throughout Europe. And by 1600, 200 million new books. That's a huge increase, of course. Nowadays, we have the internet and the World Wide Web. And so in blue here, we have some modern incarnations of these sorts of innovations. So another historical innovation of great importance was the compass. And I say this enables hereditability of fitness because it enabled travel and also to spread innovations and to learn about innovations. So it was very important for as an enabling innovation. Now again, the Chinese came up with the compass before, between the 2nd and 1st century BC, but the applications of the compass in that case were for essentially fortune telling and just very limited applications, and not for navigation, which is what the Europeans used it. So innovation is not just the idea, but what you use the idea for and how big that use is. So when you're doing a startup pitch, you want to talk about the market size and what market, what products are you selling. That determines the innovation. You have a great scientific idea, but if it's applied to a very limited market, it may not become an innovation. So of course, this compass enabled the age of discovery, the global engagement of the Europeans, colonization, building wealth and power. Some people may say this is good, bad. This is not the issue. The issue is it had an impact on the world. And of course, nowadays we have GPS. Another innovation that enabled information to spread and ideas to spread was paper currency, replacing precious metals and barter, again, originally in China, introduced from China by Marco Polo in late 1600s, and that enabled the modern financial system, and that intersected with the Renaissance that we'll talk about to enable spreading of ideas and increase commercial activity. And of course, nowadays we have cryptocurrencies and blockchain. Another innovation that has helped in the transmission of information is the telegraph. Of course, combining various inventors in the 18th and 19th century, electricity, magnets, and so forth. Before, we had the optical telegraphs, which were basically signaling, like in the French Revolution with signs, and Samuel Morse created the telegraph system, and now we're going back to optical communication with optical networks and so forth. So sometimes innovation goes forward and old ideas come back again. So innovation is not always about the new idea, but sometimes old ideas that have new uses. Of course, we discussed this last time as a paradigm disruptive innovation, the transistor, and also enabling all sorts of communication networks. So first developed in 1947 at Bell Labs, control of current through circuits. It was the archetype of disruptive innovation, and the future may be different forms of switching circuits, such as neuromorphic computing, which is based on this Bioinspired concept. We talked about it last week with neural networks and neuromorphic, meaning based on the shape of neurons or nerve systems to create computing circuits on that basis. So now we want to talk a little bit about big innovations in history that helped create phenotypic variation. In other words, obviously these innovations did many things, but they were enabling this particular aspect of the innovation equation, as it were. One of them was domestication of the horse. This was in particular by the Mongols. It enabled travel and cultural exchange. So by seeing different worlds and bringing different ideas together, that's the phenotypic variation that we're talking about, the variation. So the Mongols had integrating Europe all the way to Asia, to China, even threatening Korea, as you know from your history, and they were able to bring different ideas together, and they were, in a sense, the first global civilization. It changed the nature of war with the Mongol invasions, and of course we have new modes of transport now that may also enable further innovation. So domestication of the horse was a very critical historical innovation. We talked about the compass, also engaging other people and hence phenotypic variation. Magnifying lenses brought new ideas. We could see new worlds, both very small worlds as well as big worlds, changing the ideas. Galileo seeing the moons of Jupiter, understanding that not everything revolved around the Earth, of course, and things revolved around Jupiter. So Robert Hooke in England and Anton van Leeuwenhoek in the Netherlands developed the microscope. And of course, Galileo, as I mentioned, and Kepler developing the telescope and enabling, as I mentioned, other developments and other ideas. That's why I put it in the category of phenotypic variation. So now let's talk a little bit about differential fitness. In other words, innovations that enable us to work better in certain environments. Now, obviously, all innovations have all three components: differential fitness, phenotypic variation, and hereditability of fitness, or the development of those innovations have all three components. But again, I wanted to characterize just to give some structure to this historical discussion. So the steam engine is one, originally with Roman Egypt, but of course fully implemented by the English with the Newcomen atmospheric engine in the early part of the 18th century, replaced by the steam turbine and the internal combustion engine. Of course, nowadays we have electric motors. Another enabling innovation was or is the steel. This is an alloy of iron and carbon for very high tensile strength and low cost. It was also developed in the ancient world, but not really innovated. In other words, not really widespread use. In the Bessemer process in Germany in the mid-19th century established this as a widespread innovation. And we have new materials such as graphene for new innovation. The electric light was another key innovation over history. Humphrey Davy developed the key ideas, the chemist in England in the early 19th century, but Thomas Edison developing this as a commercial device with a long-lasting incandescent bulb. Although it had relatively low efficiency, they get very hot, as you know, and replaced, of course, over the recent years with LEDs and other light emitting technologies. Another innovation over history has been antibiotics. And this is also an example of how innovation is not in a vacuum. It develops in a social context. So these drugs made sense from the developments by Louis Pasteur and Joseph Lister of the germ theory of disease, that there were bacteria and viruses and so forth, germs that cause disease. And of course, Alexander Fleming, experimenting with these bacteria in 1928, made a mistake, was not entirely clean and careful with his laboratory procedure. And so by accident, dropped some mold on his bacterial petri dish. Most of you are familiar with the story, and discovered that something in the mold was killing the bacteria and isolated this to be penicillin. Now, this again highlights a very important point about innovation, that much of it occurs by accident. So planning specific systematic systems of innovation are in a way not only impossible, but in effect do the opposite. In other words, how do you systematically prepare to make mistakes? All of you are top students in Korea. You all took exams to get into Digis. You did not get into Digis by making mistakes. You did not pass your exams by making mistakes. In other words, you're trained not to make mistakes, to do everything right. But then people say you should innovate. And much of innovation comes from mistakes. So it's a very difficult thing. So what is the systematic approach to making innovation? I think that evolutionary model. So then you might ask, how does mistakes fit into that? Well, remember, we have the genotype. The genotype has the DNA, and there are two sources of the variation in that. One is mutation, which is a kind of mistake, but that's not really the right word, because that mistake can lead to good things or better differential fitness. The other one is the recombination with the mother and the father during sexual reproduction. So that recombination is random and comes up with different variations. So these are all, in effect, mistakes. In other words, not predetermined results, and those lead to the variation that leads to innovation. We'll be talking about these issues much more later in the course. So again, in terms of this concept, I think this is an extremely important framework to keep in mind. We will be constantly referring to this. So I'm going to ask one more question before we end the lecture. What do you think is the greatest innovation of all time. Not the greatest innovator, but the greatest innovation. I gave you a list of some that I think are in history. Tell me what you think. So I'll call on some people. I forget who's, let's go to Chukche. Chukche. What do you think is the greatest innovation of all time?
I think the greatest innovation of all time is the change from monarchy to democracy.
Oh, that's a great answer. So I showed you a lot of products, or I should say hard things, but innovate, that's a really good answer for two reasons. One, as I see it, one is it's not just a product, but it's a system, like the Roman system we talked about. And it also is an enabling innovation by allowing more people to contribute the ideas. You improve this phenotypic variation. Next week, we're going to talk about Kim Sejong, Sejong Wang Daewang. We'll be talking about him, and we often talk about all the innovations, Hangul and other instruments, but he also created more freedom in the society and more engagement in the society. Hangul was supposed to let more people learn. So even though it did not shift, as Chuck J said, from monarchy to democracy, it was a democratization a little bit of the monarchy, and that is what helped enable a lot of innovation. That's a very good answer. Chuck J, do you want to add to that?
No, thank you.
Yeah, thanks for sharing that. Pak Minji?
Yes.
What do you think is the greatest innovation of all time? Difficult question?
It's difficult.
Okay. Let's think about it some more. Let's go to Chui Jiu. Chui Jiu.
Yes.
What do you think is the greatest innovation of all time? Remember, there's no right answer.
I think the invention of vaccine is one of the greatest innovation of all time.
Oh, great. Yes. And obviously one very important invention now, or I should say for the COVID situation. Thank you very much for that. And let's go to one last person, Yeji. Yeji.
Yes.
What do you think is the greatest innovation of all time?
I think
Don't say TikTok. I'm joking.
I
농담해요.
think development of smartphone is one of the most greatest innovation of all the time.
Great. Okay, very good. You know, that's enabling communication, information storage, mobility, all these things. Again, there's no right answer to this. So let's now talk a little bit about ancient Rome. As I mentioned, ancient Rome is the original open innovator. They came up with so many innovations. Some of them are concrete, newspapers, welfare, bound books, roads, arches, Julian calendar, battlefield surgery. And just like Chuck J mentioned about the shift from monarchy to democracy, certain system innovations were also very important. And Roman law was very important in this regard. Obviously, Rome didn't go from democracy, from monarchy to democracy, it went the opposite. But some aspects of their social structure helped with their innovation. And in fact, one could argue, based on what Chuck J said, that after they became very imperial, that's when their innovation began to stop. But in the early days, when they were a kingdom, they were one of many city-states in the peninsula of Italy, and all fighting, just like the three kingdoms in Korea. And then they developed the republic and then the empire. And in this republic, if you notice here, conquest of Italy. So Rome ended up conquering and being the leader in the Italian peninsula, and of course, eventually over the entire Mediterranean, spanning Europe, Asia, and North Africa. And this Roman Empire, what was it about that city-state that enabled it to grow much more than the others and come up with all these innovations that enabled that growth? And so, as I mentioned, the 12 tables had the Latin Rite. The Latin Rite was a ability of non-Romans to become citizens or very close to citizens. It was the intermediate rights between full citizenships and non-citizens. And so they could do everything except maybe serve in the Senate. They could own land, they could make contracts, they could do business, they could marry, and it also gave them the right to travel and everything. So as opposed to the other city-states, which did not have this right, nobody wanted to go there, nobody was sharing their ideas, no experts from other areas, no other phenotypic variation. And so those other city-states which were isolated could not innovate as much as Rome could innovate, because they attracted all different people coming in. Of course, we talk about the United States being innovative and attracting so many different people and so many ideas and so forth. That may be changing because of some politics and that sort of issues. And in fact, all around the world, there are more and more walls and separation between people, which is unfortunate, because those states that do not engage with the outside will eventually lose overall, as we'll talk about in a later lecture. So as I mentioned, this Latin Rite enabled phenotypic variation and thus greater innovation of the Roman state. And finally, let's finish with the Renaissance. And the Renaissance, as you know, one of the centers was in Florence. And so we can compare Florence to Silicon Valley. And there's an article in Harvard Business Review, Renaissance Florence was a better model for innovation than Silicon Valley. Well, we know that the Renaissance in Florence came out of a pandemic. So it's hard to say, but there's been so much challenge with the pandemic here in the world, not just in Korea, that it may create new innovation, new ideas. And I think we're seeing a lot of that. So obviously it's a big tragedy and very difficult for people, but this kind of disaster also creates opportunity. So before the Renaissance in Florence, or overlapping with the Renaissance, was a terrible Black Death or plague that killed about 40–50% of the Florentine population. There's also the existence of patronage, which is like venture capital, mentorship, which is very important in Silicon Valley as well as in Florence, a emphasis on potential and not just experience, trying to recognize who might not have all the experience, but they could have great potential. So when Pope Julius II chose Michelangelo for the Sistine Chapel, Michelangelo was not the most famous painter. In fact, he was a sculptor, but he saw potential in that. And very important about competition. And we're going to talk about competition because Korea is a very competitive society, but I think the competition is very different that creates innovation. So this is an important point. And one of the features of Florence was to seek out and synthesize ideas. They constantly changed the leadership, bringing in new people, looking to different cultures and the past for inspiration, and not just at their own culture. So let's talk about Leonardo da Vinci. I think the characteristics of his innovation, as I said, he's not maybe the most innovative for the reasons we talked about previously, but I think this is a very important starting point because he was one of the most inventive people. And he had, I would call, the 3 C's: curious, he made connections between things, and he was courageous. And the true convergence of science and art, a big topic that we'll be talking about in the second half of this lecture. So relentless curiosity, as we mentioned, he was seeing more, he would observe phenomena and see much more. You know, what was the biology of it? What was the artistic aspect of it? What was the spiritual aspect? He would see more in every image. And one of the assignments that we'll do near the end of the course will be an observation exercise where you observe something and try to be like Leonardo da Vinci and see more. He also thought much bigger, not just on a specific thing, but all the interconnections between different things. And he embraced paradox. This is a very important theme in the book Waves, where you have opposites. And this is, of course, a concept in Eastern philosophy, yin and yang ideas, embracing paradox. And as I mentioned, he was courageous. Okay, so I had mentioned about Leonardo da Vinci not being that innovative because some of his ideas of flying machines and robots did not become reality. But of course, some of his paintings did and have had a huge impact both at his time and afterwards. One of those paintings, of course, is the Mona Lisa. And this is a perfect expression of the fusion of science and art. And one of the concepts is when you look at the smile, and you look sort of from the smile from a little bit away, it looks like a happy smile. And then when you zoom in on the smile more directly, you're using different part of the eye, the smile does not look so happy. It looks a little bit ambiguous, perhaps with a negative side. So Leonardo da Vinci had a very keen understanding of science and understood that the eye is not uniform in its receptive ability, and that some parts are high resolution, some parts are low resolution, and this illusion of the changing smile comes from different parts of the eye that are perceiving the image. And when you have a lower resolution, you put in some details through the mind that you see a smile, but when you see it at high resolution, so you're looking directly at it, you see more wrinkles and you see more of an element that makes it look less happy. So as I said, he was, you know, an anatomist as well as a artist. And as we talked about before, was Leonardo da Vinci truly innovative? Well, he had, as I mentioned, some of his ideas, and this differential fitness, I put in red here, he didn't have the opportunity to really test the ideas and bring them to reality. So Leonardo da Vinci couldn't really test his ideas in a way he was before his time. And this is why innovation is not just a function of the individual, but related to the world around you. What can accept that innovation? So Elon Musk is innovative, but his type of ideas are ready to be implemented. Maybe not going to Mars, but maybe electric cars. Steve Jobs, if he was alive 200 years ago, he may not be so innovative. It's hard to say, of course, but the point is it takes both the individual and the social market framework to create innovation. Finally, we'll talk about Michelangelo, and we'll talk about this quote, Ancora imparo. This is his famous David statue, and he was very competitive. But this interesting sort of competition. This was considered a poor piece of marble, difficult to work with, and he decided to take the challenge. He internalized the challenge. He wasn't fighting with other sculptors, and he also brought the science into things. He also took up the challenge of the Sistine Chapel. So the point is, he was competitive beyond competition. So all of you were competing on the exams to get into university. That is a defined area of competition. But Michelangelo was considering competition beyond the defined area. If you compete within the defined area, you are unlikely to be innovative. But if you compete outside the defined area, and as we mentioned, you know, thinking outside the box, you have much higher chance of being innovative. And indeed, that's Michelangelo. So he combined this differential fitness to this competition, both internally and externally, and of course, doing many different things, painting, sculpture, etc. So we had phenotypic variation. So a closing thought. This is Ancora imparo, yet I am learning. Michelangelo. It's one of my favorite quotes, ancora imparo. I encourage you all to memorize it. He's always learning, not just for the exam, not just for when he's young, but actually he had this phrase, this is a younger picture of him, but this quote attributed to Michelangelo was supposedly when he was age 87. So that's it for today's lecture. We will take a break here and do the second half lecture where we're going to talk about the first 3 chapters, triplet number 1 and the prologue of the book Waves. It's now 4:12. Let's start again at 4:30. I'm happy to answer any questions for a few moments here, and then we'll take a break.